Alright, here's a video on gravitational potential energy, specifically of a bungee cord. So suppose a bungee jumps off the Royal Bridge in Colorado. The bridge is situated 321 meters above the ground. So that's our bridge. Here's our water. I'll draw a bridge right now. Here's the bridge. Beautiful bridge. Excellent. Good skills. Okay. So that's the bridge. The bungee cord has a spring constant. I'll just extract that out here. It's 32 newtons per meter. The cord's relaxed length is 104. So this is, I'll call the X cord, which is 104. And its length is 179 meters when the jumper stops falling. So this thing stretches 179 meters when the person is done falling from the bungee. But we know that the cord only goes up to 104 meters. This is unstretched. Like that. What is the total potential energy associated with the jumper at the end of their fall? Okay. So actually I drew this kind of incorrectly. Let me fix it. Is because I have the person landing in the water. That's not what's happening. So let's do it like that, right? So here's the person at 179. Yay! Here he is. Let's make the bridge a little longer. Here we go. Beautiful bridge. Very nice. Okay. So you get the idea. So we have this height up here. This. So the total gravitational potential energy will be the elastic plus the gravitational. Like this. The elastic and the gravitational. So I need to find both of these at the, it says, at the end of his fall. So right here. So, with that case, what I'm going to do is find both of these at the end. Now notice that of all this, information, in order for me to calculate the gravitational potential energy, I need the height at that location. So I need h. So if you notice, h is going to be this number, 321 meters. Subtract the 179. So let's do that. 321 minus 179. 142. Okay, so that's our h. So for the elastic potential energy, I need the 1/2 kx squared, like that. So let's look at x specifically, because we have k. We also have mass, so notice we're almost done with this problem. So let's see. When we're solving this, x is the stretched distance. So this was the unstretched, this was the stretched total, which means this leftover piece here is our x. So that means we have to do 179 minus 104. So when I do that out, I get an x, if you will, of 75. And here we go. This would be, we now have all the information for our total. So m is going to be the 51 kilograms. G is 9.81. And the height at that location is 142 meters. So plus, I'm just going to go down here because I'm running out of room, is 1/2 k, which is the 32 newtons per meter. And then the stretched distance here of the elastic squared. So I'll do both numbers separately just to show you what the numbers look like. So I get 6965.1 joules plus, now I'm doing the spring, is 90,000. So joules. So now I'm going to add the two numbers together to get the total. 96,965.1 joules. So it's actually a lot easier to write this in scientific notation. So I will. 1, 2, 3, 4 times 4. So there you have it. So notice there was a bunch of information in here, and notice how helpful it is to draw pictures. So make sure you do that in solving these problems, because it will aid you in understanding and aid you to which numbers. Because as you saw, we had to use this number here and this number here, and they both happen to be parts of the problem that we didn't actually have. So you had to use some extra brain skills to solve this out, but it's not too bad. Okay. I hope you enjoyed this video. That will be it for this problem. Oops, sorry, I pressed the wrong button. Cancel.